red. Welcome, welcome. Just setting it up really quickly for anyone joining. That's fine. I look a little bit red, but it's probably because I was at the gym. And also I need to close the windows, but it's all good. Let's see, let's start with it. We need to create this function. Ready with naive base. So def, which receives document. Okay, I have all of the parameter here's. I need to irrelevant. To word this. Let's see. That's fine. Let's focus on this, which is the important part. So it takes the word concept sample, takes the dimensional vector. You can generate simple input with this. So we can do this later for the example for testing. Use the first row between it. The inputs log cost probabilities and log are the results from the functions 5.1 and 5.3. As discussed in the lecture, the function must calculate the following each class. So I have res here. So log smooth word probabilities. Oh, why doesn't let me? Next, let's run them all. log smooth word probability. What happened? Why did it go there? Log smooth res. And we have the log smooth res here. This is fine. And then this is what we're gonna do for testing. So this one, we need this, and log class probabilities. We had it before. Log class probabilities is very at the top. Here, what's it? Log class probabilities. And we put this log class res equals to this. Perfect. And then we have the last one, which is this one. Now we can just test it, print predict with naive Bayes, and then we do the log, the document word counts, which is this one. That's what I want to do. Log smooth res, log class res, smooth res. Perfect. Now let's start. Let's call the following value for each class. The log, which we have. This we have. This we have. This we have, that we have, and then count with the input, then the class C that maximizes the sum must be returned. What does it mean? The class C that maximizes the sum. Apply the function for testing to let's see what it has. Let's just do print document word counts. Why are you complaining? Because this has to go like this. Log smooth res, but even log smooth res is not. Log smooth res is there. Or did I put it inside of a function? Nope. Maybe I'll run all. Yes. So it has chords and values. Let's see one second, this one. Why is it showing it now like that? Display, maybe. Display. None. A bit annoying. Oh no, but it doesn't run. Just do this, compressed sparse result. Print. And if it is the example document word counts, value input document pressed. What does this mean? And then word to array to array. Apply the function for testing to example word counts. Results of small data. Let's see, I'm a bit stuck. So I'll ask, how can I solve part 4? Explain it simply. Let's see. Yeah, I'm a bit stuck and it's a bit confused. That's not how it started. You know, we calculate a score. The goal of NumPy was reached to find out which class, but on a new piece of text belongs to based on the word content. So here, for each possible, we calculate a score. The class with the highest score is the prediction. The formula for the score given is this. Get the class labels in order. They appear in the logs. Max score class. Iterate through each class to calculate its score. Classes is log class probabilities. Try the score with log. Specific data when you're trying to classify. This part look at the specific words in your document you're trying to classify. This is simply how many times a particular word appears in your document. Yeah. to the start the score. With the log word itself, current class score, log class probabilities at the sum of word count, log p word class. And the sum of word count log for all the words introduced. Yeah, this is fine. If the word count is 0, so we can skip issues to avoid issues with log 0. Current class score. Take its log. So for each class you take its log probability, add it to the sum of current class score probabilities, yes, and we add it to the sum of word count in needles, log word count in the needle. That's what I want to see, the word count. Word count. Document word counts. Okay, let's see, accept it. Let's try to build it ourselves instead of using this, but let's just see if it works. Score for class 0. But are these results even correct? Yes. Highest least negative score interpretation in this case is higher than. What does that mean? Class 0 is higher. Does that mean yes? I didn't know. So it predicted it as, okay, predicted it as a class 0, which is not spam in this case, I guess. I see. Okay, so I kind of got it. So let's try to do it ourselves. Maybe just keep this. Perfect. And you start with this, so we get the classes, and then we need to calculate this. This is log PC, which we have the log class probability. So if we do, we print each of them, print log class probabilities. I need to, I deleted everything, but I need the test. Maybe this I keep. Abilities of this. Then we remove until here. And then let's check log class probabilities. So, okay, it's just those values. Perfect. So we do for C index, the value in enumerate classes. So we iterate through these classes, and then we get this C, and then we need the word count per E. So let me first, before we iterate, see the shape of, we have this, we want to document let's see the shape of this. Just this. Perfect. But it's just that. It's a bit strange. It's a 1D array word counts. Maybe I ask 1 second to Gemini. Don't change anything. I am trying to do it myself. But why is document word counts a single row? Because this is the bag of words, right? So like these are different words of the vocabulary. I have to go to the bathroom. I'll be right back. I think I'm getting it. I'll be right back. Oh wait, did YouTube launch? Let me check 1 second, YouTube. This is how it look, and I kind of want to look at this too. Like this, and then run. Empty float. Yeah, this is a bit annoying, but yeah, the probabilities of each word. And then probabilities of the class, the probabilities of each word. And the XY, the count in the input document. Plus C that maximizes the sum must be returned. Perfect. So we do this, we check, and then the class C that maximizes the sum must be returned. I'm a bit confused with this sentence. What does this sentence mean? And change anything. No, sorry. I meant this. I meant this, sorry. Let's see, the class that must be returned. Okay, so yeah, we returned the max class. So we're gonna calculate the whole thing here. So we're gonna calculate per class. So we say the probability of the class. So we get that's the probability of the class. So we say class prob equals 2. Then we saw the shape here. So we just simply say classes and we get the value, which would be the C value, no, the C index, no, yes, C index, even though it would be like the C value, right? We have it already here. No, classes, yes. C value, the probability is this one. And then with that, we sum. We're gonna use the sum of this. So we need the sum of xi I'm confused with this formula. Is the sum here only for xi or for the whole thing? Let's see. To the entire product. Ah, okay, so it's the whole thing. So we need the word I, which this means we have to go through another for loop. This is the second part where we do for word index, word value in, and where are the words? Document which we saw it, so it's the document word counts. The count this is the number of counts. It's just really hard to like get back to it when I leave it. And now I remember, yeah. And the word counts. Dios. Count small data. How do I tell it? So perfect. So we go through this ones and then if we don't want to do the multiplication if it's 0, right? I mean, we still have this. So the probability will be probably or do we ignore the zeros? For all the words, yeah, that are 1. So we ignore the ones are 1. So we say if word value bigger than 0. If word value bigger than 0, then we get the word value, which is word value, and then we multiply it by the log p is the log smooth word probabilities, and we saw it here, and then we get the word index, right? Yeah, word index. In order to get it, and I think that's it. So we do that. Class probability. So then we say, that's why we needed max prob is equals to minus infinite. How do I do infinite? Oh, that, infinite in Python. Math inf, okay, yeah. So math dot inf. Can I import it? If I do inf, can I got it from here? Import import math. Import math. And now math dot inf. And then this one. And then we say class probability, blah blah, word value. And then when we get it, we do the whole thing, which is basically this is the sum probability. Okay, yes, I have to save this somewhere. I need like because it's a sum, right? So document class sum equals to, I'll just put this thing, and then we do here, there's not 0, we have to start at 0. Then we do this. Walker the code, hello, welcome to the stream. Glad to have you here. How are you? And okay, now we do the sum, we get the whole sum. And now when we have it, we compare when we finish, right? Or word, I have to do this a bit outside first. So we do the sum, the for blah, we go through it, we do the sum. And when do we check? We're in the same class. Yes, I think we finished there to check all of it. Not making AI, I'm just learning machine learning, basically, natural language processing. I'm not an expert, I'm a front-end web developer. So I'm starting to learn it. And yeah, live streaming helps me to focus more. Because sometimes when I don't live stream, then I don't focus on it. So yes, I'm just like basically live streaming my learning process. And you? What are you doing? So we have it here. And then when we finish this, you're drinking Race Peace Day. It's because yesterday was St. Patrick's Day. And welcome to the stream as well, Race Peace Day. Okay. So that's why you're drinking, because you're from Russia? Okay, so now we compare it. If this is bigger than the max probability, then we set max probability equals to document some. Ah, okay. I mean, I think St. Patrick's Day is more like an Irish thing anyways, but you can always celebrate it. Uh, so why are you drinking? Just because? Because it's Wednesday. I mean, what time is in Russia? It shouldn't be that different from here now. Might be a little bit later, right? Might be like what, 10 p.m.? Depending on where you're in Russia, you probably have multiple time zones. And then we should return. I don't know what white moon is. I don't really drink. Let me look. White moon. No, not this. Not this. Not AI mode. Drink. What is white moon? Is this? No. No, no. This seems like UFO with cow. Should I U with cow? White moon stowed. Ah, it's a Russian drink, right? Maybe. Seems to be. Because, like, look, I not fluent or speak Russian, but I would say that's like Russian letters, right? Return max prob. Okay, let's do the test if this works. Why are you complaining, my friend? Expected. Ah, yes. Let's forget. Yeah, that I know. That I know. At least that I know. Let me see. Make sure the log class res is. No, no. This is not the problem. Or is there cannot unpack non-trivial NumPy object? Yes. And for so how do we do it? Maybe we just ask quickly AI, because I'm not an expert in Python. What brings you to the stream, Race Peace Day? Today is a bit lonely, so sometimes we get 10 viewers, but I guess the time is today a bit weird. Let's see. Let's see if it can explain the error. I'm learning Python, so that's why I'm trying to use AI to explain this. I'm not well versed in Python. I'm very well versed in TypeScript and React, but not in Python or machine learning, sadly. After document to array, we're gonna build a simple list when Python iterates. No, 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 don't change anything. I beg you. When Python iterates over this array for it displays an item from the array to be a pair. Each element is a single number, a word count, not a pair. to fix this. In no, don't fix the issues. For word index, word count, and enumerate. No, don't correct me. In enumerate. Let's see. So now what's the issue? List index is out of range. Why? It shouldn't be out of range. Word locksmith probabilities shouldn't be out of range. Where are? Hopefully nowhere. But I have to do it. It's one of my modules in university that I picked. Big mistake. Maybe in the future, who knows? But right now it's just I have to do it. I have an exam next week. So I'm trying to learn machine learning and Python at the same time. And let's see how it goes. Right now it's going fine. It's just like learning in a language is always like a annoying. For side effects Houdini. What is that? On side effects Houdini. 3D modeling. Cool. That's cool. I know from 3D modeling, I know Blender, but I guess that doesn't use that much code. Yeah, I think it's good for machine learning, data science, if you are interested. Yeah, I guess so. I just never coded in Blender. I just did like the 3D modeling. Why is this out of range? Can I print this quickly? Really quick. Just save this and print. Len. Just length. Locksmith probabilities too. Of course, because this is, it's really hard to see, but this is a 2D array. So I have to get first the class index. Oh, what I'm doing, class index. And that should be work. That shouldn't be out of. Perfect. Now let's tell AI to look at it. Okay, I finished it. Me if it's correct, but don't change anything. Yeah, so right now we're doing the naive Bayes, I guess that's the name of the, I don't even know if it's an algorithm of the process for finding out the probabilities of words. So like if you have a spam email with the naive Bayes, you can know like, is this document, yeah, with this you can know if the document is, or the text is spam or it's not spam. And then it's like a machine learning kind of process where like you have some examples, some training data that you show it, then it tells you. The requirements, however, there are a few problems. Full score. The problem asks you to calculate for each class. Yeah. And just learn Houdini framework, basic Python, and you just learning for your free time or what's for university or for what? Just you just want to learn Houdini, or did you had a reason that you learned it for it? Ah, cool. It's really cool. Okay, this guy is right. I forgot to multiply. This is the function, and I did this, and I forgot to sum this, which I have here. And then I simply have to do this document class sum, and then we do the thing here where you say like we do the class score equals to this class probability plus document class sum. Ah, that's fun. I don't know C++, but I learned C# for Unity for doing game and VR applications. What is it? Class score, this probability class score, class score. Yes. New context for Houdini. I actually have zero idea of Houdini. Like, I guess it's maybe you can tell me what you could do with Houdini. I saw like 3D modeling, but like it would be crazy to do only 3D modeling with coding, right? Or how do you do it? Uh, no, C value is actually, you are wrong, my dear friend AI. It has manual modeling and knows like Unreal Engine blueprints and coding. Ah, nice. And what is it used normally for? Games or for what? For games, films, art. Ah, nice. Very cool. Very, very cool. Maybe I look into it one day. Side effects, Houdini. Really? Ah. Normally I always see Blender, but I'm biased because I did Blender when I was a kid. Ah, this is the problem. This is the classes is just sorted. What I have to do is get is C index, see, get it from this. This is the reason of not, if you don't read the code that AI gives you, then you just don't know what's happening because it added this and this just takes the keys. So, and now what is the, why are you complaining? Key error 0, 0. Why? Log class probabilities, C index, C value is still gonna, okay, you always have to do that. Perfect, let's see, check again, dig again, babe. That's really cool. When I finish university, maybe I'll have a look into it because I always loved 3D modeling. Yeah. And I didn't study it, but I would have loved it. You're very close. That's really cool. That's really cool. Yeah. The best thing to learn the stuff as hobbies and then you enjoy it while learning. Not like me right now trying to learn this without liking it at all. Okay, I'm very, very close. You're very close. There are two small agenda. You still lock in the line. You're trying to access log class probability dictionary C index, which is a numerical. However, it's a dictionary where the keys are the actual labels. Again, C value to get the correct log. But what's the difference if both are 0 and 1? This is so confusing. Z value. Returning the predicted class. The problem is asking to return the class maximum your current code is max predicted, which is the highest score calculated. Ah, okay. Max probability. I'll just keep it here. Is actually right. Highest class. And then we do mine would put the first one, I guess. Highest class. And we just get the first class. Classes 0. And then put highest class equals 2 C value. I'm a bit confused now, but let's go. Perfecto. So now let's go with the check again. You're very close. Of course I'm very close because I'm not returning what I should return. Highest class. We return highest class. And please let me go to the next exercise. I beg you. I really beg you. Let me give you the answer. Just check again. So you see the document word counts, right? So it basically has like a dictionary where, or maybe not even a dictionary, it's just like an array of words that are like unique. So for example, you can imagine here, like, you are the best man in the world and I love you so much, blah, blah, blah. Yes. So it have those words there in a index. Each one of them is like in an index. So right now this could be like the word you, this could be the word are, and this could be the word cool. So it's saying that this ones exist in this document of word counts, meaning like in this sentence. This is like basically the sentence. The sentence could be like, you are cool. And then you have to decide, and then we in prior steps got the probabilities, and yeah, it's a smooth word probability. So like the probabilities of each of these individual words to be spam. And then that's basically what we use to calculate this very pretty function. And we are done. Yeah, mother-in-law can be a single word for sure. It depends what you define as a word. Like if you want to define like it can be anything in the algorithm, you know. You can even define like a couple of words as something, or you just say like one word that is separated by space. So like if you have a separated in space, then you count it as a word. But there's also options. For example, so your internet could be me. Let me check the stream because sometimes it's me, the one who's lagging. Let me check. Test. I know, I'm fine. I think it's you. Sorry. I think it's you. Yeah. So now let's go to the second step. Instead of applying this predation to the word counts of a string, we now want to do it for the set of documents. It's okay doing this in a loop. The goal is the function here. Define this. Sorry. Excuse me. So we're doing this in a row. So we receive the apply the function counts model from step up for testing. To count small data. Okay, so let's see what we need here. Let's do print. Oh, my phone is dying. Let me have it. Is your internet again? Race peace day? Is it good again or still bad? Perfect. We print these things to see how they look. And let's call the function with count small data. Log class probabilities is log the same. There should be a list of return classes in the same order as the word counts. To count small data from step 4 for testing. Let's look at it later. But log class res, and then we also get this. A bit unsure about the one in step 4. Count data. And then let's do the print and see what's up. How do we, this is what we kind of have to do. Document word counts at the beginning, just so we can see it better. If not, it looks terrible. Why is it here? Nice look where the whole word counts. Why is it? It's here. Wrote it wrong. A nice look where it's not associated with a value. Yeah. It's till it's that. Let me see how to return it in a nice way. I see this when I print document word counts. No. No. And I look at the result. How can I print it nicely, Please don't solve the exercise, I beg you. No. Want to see the nicely. No, this is too much. No. So we just get the matrix is as parsetons with m documents as rows and n words as columns. So it should be a list of predicted classes in the same order as the documents. Predict classes. Don't solve it. How do I iterate over it? Don't solve it. So you can process each document. The first to convert this parameter into a NumPy array is into array method. I did that. Okay, I'm tired of this thing trying to fix it. I'll just do for in for word counts in document word counts print word counts get it to array. Ah, nice. It looks like this. Perfect. This I will move a bit up just to just see the beginning. Maybe no, maybe it's adding too much noise. Let's have it down. And let's see. So it looks like this, and basically what we have to do is apply to each row. Basically we do, oh, this looks a bit weird. print word counts to array because it's NumPy. Let's see. Then we do the function that we did before. Predict knife base with word counts with log class probabilities and this one, which are the same one. Then it said that we need the goal applied blah blah blah. Instead, the goal where there should be a list of predicted classes in the same order as documents. So we just have a predicted classes list, and then we simply just do predicted class equals to this, and then we simply append it. So we do predict classes list, append, and then we append the predicted class. And then we return the predicted classes list. Let's see. Oh, this looks terrible. What are we printing? We're printing return this. So we have a lot of prints there, right? Maybe we hide the prints now that we finished this. And then we run everything. Yes. And then we do this. I don't know why it's already printing this. And I do the and didn't print anything. Why? It's very funny. Everything. Hi, babe. Hello, sorry. I'll be right back. I have a call, but I'm here. Hello, Hamza. Welcome to the stream. Yes, sorry, I was a bit in a call. If you want to study, if you want to start, depends why do you want to learn coding? Maybe we can start there and then I can help you with ideas. And thanks for coming to the stream. I was just a bit on a call. Are you still there? Hamza, sorry. Maybe you're still not here because I was a bit out. Mm. Yeah, I'll prepare the second exercise. You want to become an AI engineer? Perfect. So I think then you would have to learning Python. That's the first thing you should do. So maybe let's see, best Python courses for beginners. Don't pick any bootcamp. That is not good for your money. Let's see. No Udemy. An hands-on interactive learning via data camp. Let's see. Beginners. Let's see. Maybe projects. This one. This one for sure. There is this course. When I learned to program, I also did this, and it was for Java at that time. Python was popular, but Java was like the thing that everybody used at work. But this programming course for beginners, that's how I learned it. Not the Python one, but the Java one. Really good. Just go through it, do the lectures, and then with that you'll be able to learn how to code. I'll send it here. For sure, those when I did it, the Java one was excellent. Like it really, I could recommend it. Like it's really good. So if I were you, if you don't know anything about coding, just start there and start doing the course and learning how to do it. Thank you, Ashmit Pahal. Thank you very much for the good luck. We just finished the exercise number 3 and we're going for the exercise number 4, which is regression. Maybe we should watch a video about regression, a short video about regression, maybe not super long, so we can understand it better. I think YouTube and Twitch allow us to look videos, right? So what is regression in machine learning? Linear regression in 3 minutes. Which one do we want to watch? Well, linear regression for machine learning. Yeah, perfect. That's a good start. I like math, but like, look, and this is an AI engineer for you. Sorry for stopping it. I forgot Hamza, that you mentioned that you wanted to become an AI engineer. This is a video from an AI engineer, so let's try to see what regression is. Oh my god. Sorry, I'll restart it. I think you cannot hear the screen. I'll do it again. Sorry.
I have a confession to make. I don't like math. Well, at least if you're like me, you might not like pure theoretical math. Whenever I would be sitting in my math classes, like calculus or algebra or trigonometry, I always wondered if I would ever have to use these concepts. However, if you're like me, you might love computer science. I love computer science because it helps us explain math topics in a way that's easy for our computer to understand.
It's a lot of
And
introduction
for
for
me to understand too.
little info.
When we're studying topics like machine learning and artificial intelligence, it's important for us to be able to explain to the computer how to apply mathematical concepts to large amounts of data. So one important topic in machine learning is linear regression. You may have heard of the term linear regression, and you're not sure if it's a good fit for your data set. Well, look no further. I'm going to explain what linear regression is at a basic level and give you a short example
Anytime,
of
Hamza.
what we use in a data set with two variables.
Thanks.
Linear regression is a form of supervised machine learning, which means that it uses a labeled data set. We're using linear regression to make predictions on continuous data, which is numerical data that can have infinite values. So continuous data can be something like height or age, or even foot size. This is in contrast with categorical data, which have finite distinct values. This can be things like color or the species of an animal, like a cat or a dog. These types of data would probably not be a good candidate for linear regression because there are finite types of categories that they can be in. However, if your data looks like this, let's keep going. Let's take a look at this graph. Let's say, for example, we want to build a machine learning model that will identify.
How long time required to become an AI engineer? So first, I would start, I'm not an AI engineer either, but I'm a web developer, so more of a software engineer basically with everything, but I work as a web developer. If you want to become an AI engineer, I think first step is Python. So learn Python, do the programming course that can take a couple of weeks to a month or something. And then start developing AI stuff. Look for projects, look for certifications, look for things that you can do. And yes, maybe if you have the ability to enroll on a university, then also do it. That works as well. It's really hard to tell you what an AI engineer is because also the thing is very new and hyped. So would you be the one like this woman here training the data, or would you be more the person who like knows how to use AI in a company? That's something that I guess you will have to decide. But yeah, if you have the possibility of enrolling into some kind of university or getting certificates on AI engineering, it might work very well because, like as I said, it's a bit of a big topic on what an AI engineer is and does. But then having those certifications at least will help you land the job. And then you can learn the topics on the side as well.
If there's a positive correlation between a person's height and their shoe size. And we have a bunch of data points that we want to use to predict those future.
No problem. Anytime.
So let's see if there's a.
If you have more questions, very happy to answer.
And shoe size. Right now, height in inches is our independent variable x, and shoe size is our dependent variable y. We want to model the relationship by x and y by plotting all of these points on the graph and then finding the best fit line between all of those points. So, for example, let's say that we have a data point where a person who's 62 inches has a shoe size of 6, a person who's 63 inches has a shoe size of 9, 64 inches has a shoe size of 7, 65 inches has a shoe size of 7, and 66 inches has a shoe size of 8. Now keep in mind, I actually am 63 inches and I have a shoe size of 9. So now that we have this data, let's try to find the best fit line between all of these data points. Just by looking at this, we'll probably do something like this. That would be the best fit line between all of our data points. It allows us to see a trend in the data and make predictions, And it also allows us to identify outliers, such as myself. Overall, linear regression is a great algorithm to start with if you're just getting started with machine learning models. You don't have to love pure math to work with machine learning and AI, as long as you're able to recognize relationships and patterns between data and you have the passion for it. Overall, happy coding. Thanks for watching. In the comments below, please feel free to make your own predictions about how linear regression can help.
Perfect. So let's start. We kind of got it. It's about the correlation between data sets, so like height and what was it? Foot size. So let's start going through the exercises. So this is already done. Same reel that again. Download the following thing. It's already downloaded. Tweets, blah blah blah, blah blah blah. Clean and convert data. This is the solution? No. This is not the solution yet. And is also a repetition of last year. We're saying okay, the data was cleaned. Same love from Germany and Colombia. I'm living in Germany, but I'm from Colombia. Love. Perfect. Evaluation of the selected class. We perform only one class. Label and prediction were either minus. No, really. Now it is extended to be multiple classes. Class that outputs 4 with precision. Recall score, F1 score, and MCC. Oh, MCC was very long for selecting for this. It's simpler. Label counts. Do we have it here, the function? Someone said gives us the functions already. No. Then they can be translated to 0 or 1. Then what do we do? I think let's check 1 second an old exercise. And what was it? The exercise 2? I think we did all of that. Thank you for subscribing, Hamza. Very nice. What was it? It was in here. This is what we need from the old exercise. So we do this import with all of that. Dictionary with labels, selected clouds. The 4 conversion matrix values, as well as precision, recall, F1 score, and MCC for the selected class. So let's start. We have define the function here. Oh, we've gone a bit crazy here. Yeah, so as I said, I would recommend you start with that course whenever you have time. Very, very clear. It took me, I think, maybe a month to go through the course. It's lengthy, but it really helped me to understand coding. That was years ago, though. And yeah, start there. Wait, I'm gonna wear something. I'm a bit cold now. I'll be right back. But let's keep going. It's been 3 days to start to learn. Yeah, but you can start already, no? Like even today, if you have time. Best time to start stuff is today, I think. I always say that. So it wants it puts the 4 confusion metric values. So confusion matrix, that is learn. It's the y true, y pred labels. Predictions with labels and selected class. Let's start with the beginning where we print what we're getting. Print predictions with labels, and then we print to see what is what we have, and then print the selected class. And then where is it? What is what we should pass? Valid for one. Prediction with labels df on predictions with label df. I think at the beginning up. Let's go up. There's no more. 10, 9. Let's go. Where is it though? It's in the description. I don't see the prediction with label df. I guess it's just small data df. So we call it here. Evaluate for one class. Then we do the it is equals to small data df, and selected class is 1 or others. Okay, perfect. So now we just print it and see what we get. We have to run everything though. Run everything first. I'll put some music too, background music, because I think it's sad if there's some music. Let's put some. So I don't know, this will have copyright. No copyright, please. This might be a bit too much, right? No, it looks terrible. Something chill. Nothing crazy, please. Yeah, this seems good. Okay, small df is not defined, but if we run everything, it probably will be right. Yes. That's the prediction for label, the selected class, label, and prediction. Labels. Evaluate for one class. Perfect. So this is the class just number, and the prediction with labels is just this thing. And then we need to do the confusion matrix. We do y true, y pred. I kind of forgot how to do the data frame, but I think we have here the documents, projects. No, not this one. This was an the called Anki ls. Yeah, and we do glow here. Yeah, so we have the pandas cheat sheet that we can watch. Excellent. And let's do this. We get the confusion matrix equals how the confusion matrix label plus prediction for all this, all entries are initially considered false and all that are equal are considered true. Then the evaluation is performed to the sufficient. Okay, so we first have to like go through all of this and transform it. Or this label plus all for this label plus prediction that are equal are considered false. So we clean this and we do in this prediction label data frame copy data frame equals to this dot copy. We copied first to be not make any crazy, and then we remember something nice here where we did, or is it? It was very nice. Yes, here modifying columns. So we say equals to auto set a new column pass with true or false. I don't want true or false. I want 0 or this example is nice, but what if I wanted to do 0 or 1 instead of true and false? This is in the cheat sheet we made. Let's see. So cast it to int. It sounds isn't there a nicer way? It means your parses. No, there's not adding, modifying. cast it to int. Okay. Okay, so we say label is equals to, and we say here display is better, I guess. Label is equal to this label and equals to selected class, and then we do the whole convert into int as type int, and then we don't do this yet, and then we are gonna actually show the copy one. Label, yes, and then we do the same for prediction. Prediction. That's nice. Okay, we did the first step. For this that are equal to this letter are all equal. Then the evaluation is performed on this. So we do confusion matrix equals to, maybe here, cm confusion matrix, and then we do what is exactly label and prediction. Copy df, maybe, so we don't have to repeat ourselves. Yeah, true, white, red. So we do the true, and then we do prediction. Perfect, and then we do this, basically. This is nice. And then we print confusion matrix cm equals to cm. So we have true 6 true negatives, 0 false positives, 1 false negative, and 1 true positive. Two true positives. Perfect. That's nice. So let's see. The next one is that maybe what I should do is organize this. Sometimes having to read it every time is a bit annoying. So we need precision, which also we have here. Precision. Precision, recall, and F1 score. And I think I would just print all of them. I mean, I don't need to, those are just values. Yes, blah 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 for the clarity. Also print which concept will be evaluated at the beginning. Should also contain the pandas data temperature with labels df. Should also contain the column prediction and label each one with one possible classes. Yeah, we have that. Like the function for testing. Yeah, by the way, it's able to allow functions to call with parameter names, not just via the parameters. This can be achieved by writing before the first function parameter. Do we have an example? In practice, yeah, I don't really want to do it right now. And then what should it return though? Ah, okay. It outputs, I guess, it means it prints them. So print selected class. Oh, we say selected class. We have this, we have this, we have this, we have all of this. We printed the beginning, so we don't need this. We have this. Maybe we print this also the beginning. Then we do this, and we say confusion matrix. Then we call this precision score, recall score, and F1s. This we do here, and sorry, F1s, F1 score, and we do F1 score. Then recall score, we have recall. Perfect. So if we play this, we have an issue because we don't have this yet. Yes. Vision matrix score function F1 score at. It's funny. How do I print the function one score? I call the function Amsterdam. Let's do this one here. Yes, that's the score. Perfect. So let's go with the next one. Let's see. We also want to wait to access the prediction. Okay, we did this already. We also want a way to access the prediction quality. So to do this, write a function. Maybe I will ask this, yeah, because I don't understand this. What is with this? Now I'll prepare some topics here. Claude. Not here, sorry. ct.ct Claude Anki Claude. Then I'll do resume. Create Anki cards for the next 3 lectures. Remember that Okay, so just that. Very clear, actually. So we want to reduce the predation quality across all classes. Actually, I need to take a break, guys. Or I'll take a break. No, I'll take a break now. Thanks for everyone watching the stream. I don't know if Hamza or someone's still watching the stream. If not, then thank you. And I'll stream tomorrow a lot because I have more time. Thank you. Bye bye.